Can't even get the connection on. All right. My name is Devinder. Excellent. All righty. I am a consultant and a founder. I started out at companies like Johnson & Johnson, Canfield Scientific, where I helped them build complex systems and software. I've worn all the hats: software engineer, TPM, product owner, anything related to software, I've done it, manager. And so today, is it up yet? Is it showing yet? It's showing you trees, guys. Let's see. Aha, I can drag it. And then, good enough. Okay. And I'm also building this technology that helps automate a lot of the regulatory work in med device settings. Really, this can be expanded to any regulatory framework, but the idea I think we want to get to is how do we navigate all these new AI technologies coming up in software, and how do we deal as software engineers with AI itself? So, what is sort of the general feel for AI in this room? Is everyone positive about it? Lots of positive people. Is anyone worried about it? All right, we got a mix. All right, good. So I don't know if you could read this quite as well as I hope that you could read this, but what these are essentially are quotes from the two Marks, the Mark from Meta and the Mark from Salesforce. They're kind of telling you that software engineering is something that's a solved problem in AI, right? And that's really great input for leadership, because we can really take in that information and figure out what to do with our future. Like, we don't really need to hire software engineers anymore, except that Elon tells you that we have a permanent shortage of software engineers, right? Who do we listen to? Like, you need some guidance to figure out how to deal with software in general. And are we even going to have software engineering jobs in 10 years? And so the question is this, right? What does that mean? Is it a threat? Is it an opportunity? Is it a little bit of both? And I like to work in the framework that this is an opportunity. I think as AI improves, we're going to change the standard that people and our customers expect from our products. And we're going to completely change. Oh my God, am I still wearing my book bag? And we're going to completely change this whole idea of what an acceptable product is in a professional setting. And all of a sudden, you'll need technologists again. So let's work through. Have we ever seen something like this in the past? Like in the beginning, we had punch cards. And nobody sees punch cards anymore, I hope, right? And then we got mainframes, and almost nobody sees mainframes anymore. And then we had PCs and the web, and technology started moving forward a lot. And then we had these boot camps that in 3 months could teach you how to code. And some of those people had success, but there was this huge thing: software engineering is dead. It's gone. You don't need it anymore. You can learn it in 3 months. And now AI is doing kind of the same thing, but you can do it in 1 day. What hasn't changed is that we still have professions in this field that are delivering really high-value product, and we just have to sort of rethink how we deliver it. I built an app recently that uses this framework that I have, and it changes the way you think about AI. There's a few things. One, if AI isn't 100% perfect, can we trust it? Does anyone believe that? No one in this room. You'd be surprised at some of my customers, right? If it's not perfect and we can't necessarily trust it all the time, how do we use it? I'll give you an example through medical devices. This is an app that I built. So in medical devices, if you've ever built a robotic device, a class 1 A, B, C, you have a bunch of challenges. You have these things called CAPAs, corrective actions, which basically means that you make a mistake, you can't live with that. You have to fix it before it makes it to your customer, right? And you have a bunch of complex regulation. The FDA is saying one thing: you need new security, you need new AI regulation. And there's all these siloed teams. It's your software engineering team in one place, and then there's your quality team in another place, and then there's your regulatory team, there's your QA team, there's your test team, and they don't always talk in the most fluent way. Sometimes things get left behind. And what this means at the end of what we call a development cycle is that you have to get to this, your validation and your verification cycle. It takes like 3 months to sync up on all the documentation. You have software design documents, you have development plans, you have hazards lists, you have a ton of things that need to get synced up. And it's typically manual. And I will tell you, from my entire team of 30 software engineers, 0 of them like doing it manually, right? Zero of them. Inevitably, if you don't love doing something, you're not going to do the best job at it, and it just takes more time. So how can AI help? We got real-time validation that we can do now. It's a low-hanging fruit item. We can actually utilize LLMs, then RAGs, now re-rankers, all these technologies that are getting better and better to do some of that work for you. We can actually provide a pretty good idea of what your document should look like based on some software changes you made. And we can give you something that's ready to sign as a software engineer. And as a software engineer, it's still on you as a subject matter expert to figure out, is this the right thing? Am I changing the right stuff? Is it the right test? But if I do most of that work for you, or if I bring you the test, if I give you the changes to the documentation, and if I tell you some of your code's not compliant, you can't even get past what we call a pull request, then you have something going on there that kind of builds this entire regulatory framework into your work, right? So this also has this side effect that when you have all this information about your software, all of a sudden, if you make a change to your hazard list, this automated hazard list, your quality team's automatically notified, and they become part of your process. They're not learning about your device 6 months later when it's time. They know all of the changes in your device as they're happening, right? And that's an amazing thing because it's possible now with the technology we have now. All you need at the end of the day is your human in the loop, your subject matter experts, to make sure that they're doing the right things. So in the interest of time, I'm just going to quickly walk through one developer-related thing. You have your code march, your AI checks everything, you create new dashboards, you make sure your hazards are in a good place, your data is secure, you update all of your documents, and then finally, your subject matter expert kind of give you the oversight. So why does this matter? This means that your 12-month cycle in your $100 million business could be a 9-month cycle. That's, that's huge savings. And your quality isn't going lower. It's not like AI has to be perfect. AI is actually going through much more of like the newest sort of like requirements that you have, the quality best case scenario that we hope for, and advising you against those standards, right? And now you're at much higher quality than you've ever been in the past. It's not a matter of are we hitting 100%, we're well past. And so you have empowered engineers because they get to work on more fun things. They don't have to deal with documentation. And you have happier partners because your quality team is actually in sync with you and they know what your product does right off the bat. So if you build software in this way, you could go a lot further. You could adapt to new regulations much faster. Like if you have to go to Europe, that's not a big change anymore. You have an analysis system that'll help you from your US-based system to your Europe-based system by just doing a diff on that and giving you a lot of input on that, right? Your regulatory team is going to be way happy. Then you have an extensible engine, and then finally you can expand this to your hardware teams, your marketing teams. All these can kind of benefit from this. That's the gist of it. If you liked what I had to say, there's my LinkedIn. If you want to learn more about stuff like this, and I'm happy to take questions.
Get your questions.
Yeah, I'm curious from your perspective, like when you look at some of the biggest challenges that you're trying to overcome and just that reflect the early nascency of the overall efforts that are AI enhanced, what are some of the things that you're keenly focused on overcoming?
Yeah, it kind of depends on the size of the organization. I implemented some of this at Johnson & Johnson, and there's some regulatory aspects and like just getting your team to commit to the spend on XYZ is a really difficult task. But there's also other challenges. You have to train your team to be more like AI-centric. That's a mindset shift, right? I literally get hired to do this for entire teams where people are tried a couple of things on their ChatGPT app and they're like, this is crap. It didn't give me the thing I expected. It's over. So there's a bunch of these tiny little challenges that stack up. But the wins are so overwhelming that it behooves us to try to tackle some of those challenges. Thank you for the question.
Here.
Yeah.
Thank you so much. And actually, this is, I think, a follow-up to your previous answer. So basically, as a tech lead as well, I also see that a lot of engineers are actually resistant to AI adoption, right? Many of them, in fact, machine learning guys are quite like skeptical, but they don't use it, right? Just because it's like at least the ego issue, right? So, that thing knows more than I do, like, fuck it, right? So how do you, like, you've mentioned that you did like the Mindshift stuff and things like this. Can you elaborate more on that? Like, what was your strategy? Like, how did you really push through the AI usage and adoption?
Yeah, I'm going to focus, because this is such a big question, I'm going to focus on the engineering component.
Yep,
right?
thank you.
First, you have to really figure out what they don't like. Sometimes an engineer is like, well, I build machine learning systems and they don't do X, Y, Z really, really well. How could you have possibly done it? I don't think it works well. I tried it once, it didn't work. You get a bunch of things like that. And then there's who are kind of resistant to like learning anything new. I don't think that's real software engineers. But anyone who's in a mindset to learn, what you need to give them is like, yes, we understand there's a saturation of these tools in the market and no one's won the battle yet, right? And so let's pick 5 of them, do a POC. If you do spikes, do a spike. Try to learn a little bit about them. And then let's get someone in who actually understands how to use them. Read those docs, right? If you understand that you can build context into, say, your Copilot or your Cursor or your Windsurf, and then you understand that, oh, not only that, I can work with much larger workspaces. On day 1, it was 5,000 lines of code max. Today, you can work with 1 million lines of code and still maintain context, right? As you talk about the evolution of these tools and where they're getting, and specifically what engineers love to see, what the limitations are very clearly, then you know how to use them. And if you explain the limitations, they know what this tool is good for, and that's when you start to see sort of a mind shift change. Mindset change.
Thank you.
Yeah. Hopefully that was helpful.
That was a mic drop presentation.